Hi, my name is Denis, developer advocate at the United Manufacturing Hub. In this video, we are going to explore HighByte, and more specifically, we're going to integrate it with the UMH stack. This video will consist of 3 parts. In the first part, we will learn how to install HighByte by downloading the Docker image and building this image locally on our computer, and then pushing it to a remote private repository on Docker Hub. In the second part, we will pull the image from this Docker Hub repository to create a new service on Kubernetes inside the UMH stack. This way, our UMH installation will run parallel to our UMH deployment on Kubernetes. And then finally, once we have HighByte up and running, we will build a simple MQTT pipeline that will pull data from the sensors of the UMH stack, so the humidity, temperature, and pressure, and then we'll process this data by adding a timestamp and writing this data back to a topic on our UMH MQTT broker. So the idea is to give you an overview how HighByte can be used in parallel with the UMH stack to read, process, and write data. So let's get started with the first part. I'm here logged in onto the UMH website. I had to open the website in Google Chrome because on Firefox, which I normally use, I couldn't see most of the forms. So once you're inside, you're in the HighByte portal, in your account, you can go to download product. And here you see various options. Now I decided to take a risk and go for the latest version, which was released relatively recently, namely version 4.0. And we want to run HighByte as a Docker container. For more information about running HighByte as a Docker container, you can refer to this website, which will be linked below. But essentially, it explains, once you have downloaded the image, how to run it. So let me switch back to Google Chrome. And I'm going to download the HighByte Intelligence Hub Docker image. I'm going to accept and download the license. And the image will start to download, and it will complete in about 1 minute. It's a relatively big image, it's half a gigabyte, 600 megabytes. In the meantime, we can look at the commands we have to use. So to run the image from Docker, we're going to load the image that was downloaded. And after that, I'm going to rename the image so that it fits the name of my repository on HighByte on Docker Hub. So I have built a repository in my Docker Hub account called HighByte, and I already have an image here, which I have called control-d/HighByte with the tag 4.0.0, but I will, for the purpose of this video, push this image again. So the download is complete. We can now go to the instruction manual on Docker. So essentially, we want to use the docker load command. So if I navigate back to my terminal, I see that I have the image in my download folder. Can make it a bit bigger. Right. So if I now use the docker load command, and I don't have rootless Docker, so I have to add this sudo, I see that I can do it here. Add my password. And the image is now loaded. So if I do docker images ls, images, I see that I have the HighByte image here. But what you would like to do is essentially tag this image in an appropriate way. Docker image tag, I think. Yes, so we want to rename the original image, which will be HighByte 4.0.0, so that it matches, first of all, the name of my Docker Hub account, which is Goncharoff-D. This will be different for yours. And on Docker Hub, I have the repository called HighByte. And the image tag that I will use will be 4.0.0, which just reflects the version of HighByte. You can find out these values by navigating to your own Docker Hub account. And here is essentially my account name. This is my repository name. And this will be the tag of my image. So we will see this value of pushed change. Right, so first let me change the tag. That's now done. And now I'm going to push the image to Docker Hub. Sudo docker push, and then I simply I push the name of the image. Right, so it's now preparing. I have to log in first. So let me quickly log in. Okay, so I'm now logged in. Now I can push the image. And because I have already pushed the image, all the layers already exist. Essentially, nothing really happened. But if we navigate to my Docker Hub account, here, I see that essentially I have pushed the image a few seconds ago. Right, so now we have our image onto Docker Hub, and we can start configuring the second step, namely creating the appropriate Kubernetes deployment. Okay, now that we have our HighByte Docker image stored in our private Docker Hub repository, we can now use it to create a new service on Kubernetes that will pull this image and create the HighByte container for us that will be managed by the Kubernetes alongside the rest of the UMH services. Before I continue, let me quickly highlight where I have the UMH stack running. Essentially, I have deployed my UMH stack as a Flatcar Linux image on my virtual machine managed by Proxmox, but you can have your UMH running anywhere you want. It can also be on Ubuntu, or it can be some virtual machine in the cloud. Because we are essentially installing the image inside the UMH stack as a Kubernetes service, it really doesn't matter where your UMH lives. Okay, so let me navigate to my terminal. As I mentioned earlier, we're gonna pull the image from our private Docker Hub repository to create the HighByte container on Kubernetes. Well, because the repository is private, we need to authenticate Kubernetes, otherwise it cannot enter our Docker Hub repository. And for this, we're gonna create a Kubernetes secret. Now, the command to create a Kubernetes secret is essentially kubectl create secret. And then my registry key will be the name of that secret. I've created a file that you can reuse with the command that will create this secret if you copy paste this into the onto the command line inside your UMH. But let me go quickly through it. Essentially, would have to define your Docker username, your email, and then your password. And then you can just copy paste all of this once you have filled this in. Open a terminal, SSH onto your UMH installation, which in my case is Flatcar, using the UMH password, and just copy paste your code here on the command line. Now, I'm not going to execute it because I already have created my secret. As you can see, right, with this command, kubectl get secrets, don't forget to specify the UMH kubeconfig, which is stored here in the etc rancher directory. And don't forget to supply the namespace, namely United Manufacturing Hub. Here you will see the secrets that exist by default. For example, the Grafana secret that you use to authenticate and view the dashboards. And here at the bottom, you see my earlier created registry key. Okay, so this key can now be used by Kubernetes to authenticate to our private Docker Hub repository. Now let's look at the actual Kubernetes deployment file that we will use to alter or to extend our existing Kubernetes deployment. I have the file here on my computer, but it will also be linked below the video. Essentially, we are going to deploy 3 additional services. First of all, we are going to pull the image. This will be the actual new container containing our HighByte installation. And as you can see here in the image pull secrets, he is going to use our newly created registry key to authenticate. We're also going to expose some container ports. Port 45245 will be the port on which our HighByte intelligence hub will be accessible once we have it up and running. There's one more thing we need to do. First of all, the HighByte recommends having a persistent volume. This is convenient in case your container goes down, but you don't lose your data. This is really to persist your data. And for that, we have essentially created a persistent volume claim in Kubernetes. And the third service finally is to be able to access our intelligence hub outside of our virtual machine. So in my case, I want to open up the HighByte intelligence hub in a web browser on my host computer. We have to expose the ports using a Kubernetes load balancer, which again is defined here as a third service. So this file, I have it also an exact copy in a folder HighByte on my VM, where you see the deployment YAML file. It's written here. So you'd have to copy paste this file to your UMH stacks command line. Then the command we're going to use is this one. So sudo kubectl apply, and then we're going to specify the f as a file. This will be our deployment YAML file. And again, we specify the kubeconfig. In this case, we don't have to specify the namespace because I have specified the namespace here in each of the three services. So once this is complete, you can press enter. And given that I already have this deployment, nothing really changed. But what I can do, if you're doing this for the first time, we can observe the pods by using the kubectl get pods command. Again, don't forget to add the namespace and the kubeconfig. And you will see a lot of existing pods which are already given to you by the UMH stack. But here you see our newly created HighByte deployment. It's ready and it's up and running. So if you follow these steps, you will have, hopefully, there we go, on your IP address of your virtual machine where Flatcar is running, on port 45245, you will be able to access the intelligence hub. You don't need to supply the password, you can just click on login, and there we are. Right, so to recap, in this part of the video, we used the Docker image in our Docker Hub repo to create the HighByte Kubernetes service that we are going to use in part 3 to build our pipeline. All right, in this third and final part of the video, we are going to now use HighByte to build a data pipeline that will process MQTT data from the dummy sensors provided by the UMH stack, namely the temperature, humidity, and pressure. And we're going to write this result with the timestamp back into the UMH's unified namespace under the correct tag name, which includes the historian, so that the data from MQTT will automatically be saved in the timescale.db UMH historian. Now, for this, we'll have to configure a number of steps in HighByte. First of all, we will have to define a new connection with inputs and outputs. Then we will configure a model. HighByte works with so-called data models, in which you specify how data is structured. Once a model is created, we will create an instance of this model. An instance is essentially an actual variant of a model. So if, for instance, a model is an engine, then an instance would be engine number 25 running in that particular machine. And finally, once we have our instances ready, we can use them to build data pipelines that will read from our inputs defined in the connection, process data and then structure it given the specification in our instance. And finally, we will write this data again using the outputs defined in the connection. So that's how it works on a high level. Let's now go through each of these steps step by step. Right. So as a connection, I already have a connection created for the UMH, but essentially all I did was to click on new connection, give it a name. The protocol is MQTT, and as a host, I supply the DNS name of the UMH MQTT broker. The port can be 1883. We are using unencrypted traffic, and the rest of the options you can leave as default. Now, once you have defined the value in the overview, you can go ahead and save this. And I define a number of inputs. So essentially an input is when you give it a certain name. For example, the data from the humidity sensor, which is packaged by default with the UMH stack. For this, I give the name humidity_in, and I explain where this data can be found, which is essentially just the name of the topic. And as you may know, the UMH broker publishes this data on the IA, raw development, IoT sensor, humidity topic. The rest of the options you can leave as default. Save it, and I have done the same for the pressure and for the temperature. Right, so once you have the data, you can actually also test it by clicking on test input, and you will see that we indeed get the value for the temperature that changes every few seconds. So once we have that, we can also define the outputs. Now the outputs will be a topic on that same broker, in this case the UMH MQTT broker, in which we will write our final result. And just for the sake of this exercise, I will create a new output so that we can inspect it in the MQTT broker. So I will call, yes, so first of all, we want to adhere to some degree to the UMH's historian name structure, because again, we want the data to be visible in timescale DB. And for this, we want to have our data adhering to a particular structure. And that you can find here in this article that will be linked below, which explains you the schema that you need in order to have the data saved in the historian. So essentially, we need a structure that has UMH, v1, and then corporation name, location, machine name, underscore historian, which is important. And then you can define groupings such as head and position for this particular sensor. Right, so let me call this HighByte underscore demo. And I will write it under the demo tag, under demo grouping. So we will later inspect this particular tag in our unified namespace and to see if we have data being published there. Okay. Now we have our connection and inputs and outputs defined. The next step is to build a model out of this data. Now I already have a model here, and we can essentially reuse it. Let me explain how it works. So when I create the model, we define its attributes. An attribute is a value that this data model will have. In this case, my sensor model contains 4 attributes: a timestamp in milliseconds, which again is required by the UMH stack, unified namespace, and then the values for temperature, pressure, and humidity. You can add new attributes by clicking on the plus sign and then on enter. And then for the new, you can essentially configure it as being an object or an internal value. You can assign a type to it, for example, or a floating point, and a description and a default value. You can also remove any created attributes by clicking on the red sign. So let's go through them. For my timestamp, I've essentially defined to be an internal attribute with an unsigned integer of 46 bits. A temperature, pressure, and humidity are all just floating point numbers. Remember, in the model, we don't specify where the data will come from. We just specify what the data is. So in this case, our sensor model contains 4 attributes, a timestamp in milliseconds, and then the 3 floating points. Now, in a later step, we will create an instance of this model, which I have conveniently called sensor model instance. And the sensor model instance will essentially use our model that you can specify here. And the difference here is that now you have to specify how the attributes will be populated, so where the data comes from. For the timestamp in milliseconds, you can go here on the right and specify that this will come from our system itself. It will be an internal value, and it will be a datetime. And by dragging and dropping, you can put it here. So it will reference the system's internal datetime, and it will be an unsigned integer 64. For the temperature, we are going to rely on our input that we defined in our connection earlier. So if I just remove this, we again are going to refer to a value, but this time we are going to go to input. We're going to look at the connections we have. I have a connection for the UMH that we created earlier. I'm going to select the temperature in and drag it to the reference field. And I've done essentially the same for the pressure and for the humidity. Let's save our model, and we can click on test instance, and we see that indeed we obtain a value for a timestamp in milliseconds, which is an integer, and we obtain 3 floating point values for temperature, pressure, and humidity. You can test it again, and the values are different. So remember, we have a model, and now we have an instance of this model that has an actual values for the attributes. The final step of this third part will be to create a pipeline. Now, in previous versions of HighByte, 3 and so on, you had flows and pipelines. In this beta release of version 4.00, we only have pipelines. If you are familiar with flows, they can still be used in the beginning of your pipelines, but essentially pipelines is what we are building. And I can go over a relatively simple pipeline that I have built to read in MQTT data from the UMH broker and write it back after doing some transformations to the UMH broker. And the way a pipeline works in HighByte is that you have a pipeline defined here. You can give it a name, group, some tags, and you need something that will trigger this pipeline. And I decided to write my values every 1 second. So for this, I'm using this block, which is a bold block that I have configured to first of all be enabled. So our pipeline is currently running. And at an interval of 1 second, this block will say to the pipeline, hey, execute. Essentially forcing it to go look for a value to execute this read block every second. I'm using this read block because I am reading data from MQTT. You can find the read block here under the IO section. And if I look at the configuration, I gave it a name. I keep my input event values in line because HighByte assigns some keys by itself in the event that are processed in the pipeline. And this is where we refer to our instance. So essentially, remember, we want to read data from the MQTT broker, but we want to read the data into a model that we defined in HighByte. This way we have a nice timestamp with the 3 floating point values that currently are have those values at this timestamp. So we're gonna select instance, and I only have this sensor model instance created, which I can drag and drop here. And we can save it. Right, this means that now every 1 second we poll for values that are filled in our instance in the pipeline. The final step that remains is to write this data to a particular MQTT topic. Now for this, essentially I would have used the write block. Unfortunately, for reasons unknown to me, the write block assigns an additional key underscore timestamp, which is not so clean, because I only wanted to have the key value pairs that I defined in my instance, namely timestamp in milliseconds, pressure, temperature, and humidity. So to filter out this additional underscore timestamp, I have used a write new block here that I've connected to my read block and configured it by giving it the name write underscore UMH. I'm gonna use the connection UMH because this is the broker to which I'm writing my data back. I've defined the topic myself. This means that we're actually not gonna use the output I created earlier, but just for the sake of exercise, I will write to the demo topic, which currently doesn't exist. And the rest of the options you could leave at default, except that all the way at the bottom you have this attribute filter, to which I have added the underscore timestamp because I want this event to be not present in my final message. And we can save. Now, to see if this pipeline works, we can go to the poll trigger and first of all enable it. And if we go to our pipeline settings, it makes sense to enable, for debugging purposes, this track events ready button. This means that essentially when this is activated and the pipeline is enabled, I can go to my replay tab, clear my previous events. I don't want to only show fails, I want to show all the data. And now when I refresh, you see that I have data coming in every 1 second. And if I now click on one of those events, I can essentially see a replay. So now when I navigate to my write new node, I see that the current value was indeed a JSON object with a timestamp in milliseconds, again, and a value for temperature, pressure, and humidity. We can exit the replay. And essentially this data is now being written to our UMH broker. We can now check if this data is actually there by using the UNS Client. Right, now by navigating to the UNS Client, I can select my connection, which is the UMH, and I will list all the topics. And now when I connect, I see that under UMH, HighByte Berlin demo, I indeed see that I have values coming in. Again, so every 1 second, I get a new timestamp, and if the value for temperature, pressure, and humidity has changed in that second, I will see the actual value here on the right. So again, it's nice that HighByte supplies its own unified namespace client to simply inspect the data. Now, given that I write the data to the UMH broker, we can also use the tag browser of the management console. If I navigate to my tag browser, I see here that I have under my demo tag, I have the 3 values for humidity, for pressure, and for temperature available. Now we can use the created query to then build dashboards in Grafana, such as we have done in previous videos. All right, that's it for this rather long video. There's been a lot of information presented. So if you have any more questions, please refer to the links to all the supplied code and documentation in the links below the video. And also, if you get stuck at any point throughout the video, I would really invite you to join the Discord channel of the UMH, and post your questions in the support chat where I, but also other people from the UMH will be there to assist you. As always, thank you for watching and see you in the next video.